What's going on, guys? Today we're going to be talking about the composite pattern. And before we move on to the intro and whatever, I just do want to I want to say thanks for taking time out of your day to actually look at my videos, guys. I really do appreciate that. So, without further ado, let's get right into the video. So composites work with trees, and when it comes to programming, trees are everywhere. One of the most common trees that we interact with is the file system. So in the file system, there can be directories that can be used to group files in other directories, right? The nodes that contain groups of other nodes are referred to as branches, and the file system, a file folder, represents a branch. If we traverse a tree, we will eventually end up with nodes that do not contain or group other nodes. These nodes are referred to as leaves, and in the file system, each file will represent a leaf. A composite is a leaf or a branch, and the composite design pattern allows you to organize your objects in a way that treats leaves and branches uniformly. So the Gang of Four defined the intent of the composite pattern as composing objects into tree structures to represent part-whole hierarchies. Composite lets clients treat individual objects and compositions of objects uniformly. And we're going to be looking at that today in this file that we have. So we have, oh, by the way, I did forget to push this observer to Git. Sorry about that, guys. I don't know if you're downloading it or cloning it, but if you are, sorry, I will have that today. Anyways, in the composite, we have two files right now. We have the catalog item and the index item file. So the catalog is a class that has a name and price, and we have a getter for total that will just return the price of the certain item that you want. And we also have the print method that actually counts and logs the name of the item and the price of the item. And that's all we're doing in this one. In index.js, we create 3 instances of catalog item: dress, shoes, sneakers, flip-flops, etc. And as you can see right here, I just printed it out for convenience sake. If you just print it out right here, dress, shoes, total, you'll get the dress shoes, which is $179.99. We get wingtip shoes, $179.99. I'm just showing you that the total and the print works. That's it. But the idea behind composites is we have a single item, a catalog item in this case would represent a leaf. We want to create a class that could represent the branch like catalog group. So we're going to create a catalog group up here. Var catalog, just catalog group. And we're going to equal that to require. Let me just get the same one. Copy, paste that. So let's say that we had a catalog group class, and we could create a new catalog group like group shoes, and we'll give the shoes group the name shoes and whatever, and we want to pass in the array of items that are contained in this catalog group. So we're gonna have dress, shoes, sneakers, and flip-flops. So let's actually get that done. So below, like I said, we want to group the shoes together. We're gonna group them. Okay, so we're gonna create a variable called group underscore shoes, and we're gonna set that equal to new catalog group, and we're gonna name it shoes. I have no idea, dude. I suck at names. I'm just saying shoes group, and we're gonna pass in an array that has all the shoes that we want to group together in this one catalog group. All right. So we're gonna pass in dress, shoes, sneakers, and flip-flops. I don't know if someone's gonna argue that flip-flops aren't shoes, but I have no idea. Anyways, so this catalog group should have the same interface as a catalog item, meaning that we need methods for total and print as well. So down here, since we haven't created this, we should be able to do group shoes dot print. Like I said, it should have the same interface as the catalog item, and we need to invoke or create a print method. Okay, so let's create a new file. Do I have it? Yes, I do. Let's create a folder called catalog group, and here we're going to create a class. So class, and make sure to export that class module dot exports. It's going to equal to class. I am going to change the class name. I just wanted to do that so that way I could just do this, and we're going to name it to catalog group. Paste it, catalog group, just like that. All right, inside the constructor, obviously we're passing in a name and an array. So this dot name is going to equal name, and we do need to pass in name up here. And the second one is going to be an array, but you gotta remember, guys, that this array can be either a catalog item or other catalog groups. Okay, because remember, this catalog group is going to sort this catalog group right here is going to sort out other groups inside of it, like other files, file directories, or just plain files. Okay, so you got to remember that. So we're going to just name this second one composites, and we're going to just set it down here. This dot composites is going to equal composites. But this right here is very it's the key for this whole composite kind of thing, because it could be sent as an array or just a single node. Okay. Anyways, all right. So now we do need to get the getter for total and the print method. So get total, because remember, we do need to have the same interface, and print. Oops. All right. So for the total, we do need to give back the actual sum of all the arrays. I mean, whatever inside the array, we need to give back the sum of it in numeric value, right? Like over here, we're giving the sum. I mean, when we do print for dress shoes, we give it 179.99. But since catalog group is an array, we need to give it the sum of that array. Okay. And you can do this various ways, but I'm just going to be using the reduce method, which will reduce the entire array to a single numeric value, the total of all of the values. Okay, so let's just do this. I'm not going to really explain what the reduce method is. You can look it up yourselves, but that's not the point of this. We're going to return this dot composites dot reduce. We're going to get the total, and then next item, set that into an array or function for total, plus next item. We're going to starting at 0. Okay. So this is a reduce method. I'm not going to explain like I said, but all I'm doing here is I'm going to add up all the totals in that array, and it'll just spit back what the total of that array is. That's all we're doing with this one. Like I said, you could do it various ways. I'm just using the reduce method to do this. Going on to the print method. So in the print method, we just want to print all of the items that are saved under our composites. All right. So for example, in our index, we have shoe groups. This is a catalog group, and we just want to print out the dress shoes, the sneakers, and flip-flops. Just like we did over here, dress shoes, sneakers, and flip-flops, or whatever, just like that. Okay. So going back in here, the first thing I'm going to do is just log out. Nope, not console. Just log out. Where's my tick? There it is. With the new line, just in case something happens. This dot name whatever we name the catalog group, I just want to log that out. And I'm just going to uppercase that to upper case. Okay. And then I'm just loop through the composites to just get every one of them to you'll understand what I'm talking about. I'm just loop through the composites so that way I get everything that we have inside that catalog group. So this dot composites dot for each, and we're gonna get every item in there, and we're gonna just call the print method on that item. So item dot print. That's it. We're gonna literally just print out the items. Control save. So let's actually see if this works. So up node, and we see that we do get shoe group, and we're printing out everything that we put inside our array. We got dress shoes, which is wingtips. Shoes were $179, kicks $39.99, and flip flops $9.99. Same thing. Okay, awesome. So let's actually modify our client code just a little bit. Well, okay, I've said this a lot of times. Every time I say client code, I mean the index.js, our main application file, our client code. Okay, so let's modify it, because the idea of catalog is to treat both items and groups uniformly. So this will allow us to compose tree structures, right? So before I create an entire catalog, I want to create another group. I'm going to create a group for foods, let's say. So under shoes, I'm gonna create another variable. I'm gonna say food or group foods. Keep it the same structure, name structure, foods. We're gonna set that to new catalog group, and let's say we're shopping in a very high-end place where, I don't know if you've ever been there. I mean, I go sometimes to these very high-end places just for their foods, because they go around in trays giving you drinks and foods. I don't buy anything. I'm not rich. I just want it there because it's free food. You know what I'm talking about? They're giving you free drinks just to look around. So hey, but this is what I'm basing this off of. So you got the shoes and then the food, because we're in the side of fancy place. So I'm just call this fancy food. That's our catalog name group. I have no idea. And what they're serving in there is, since we pass in dress shoes, because dress shoes we already created a new catalog item up here. Since we don't have a catalog item, we do need to create new catalog items. So I'm just put this new in a new line and just say new catalog item, just like that. And let's say they're I don't know. Let me see. Let me think of some foods. Honestly, I don't know the names of those fancy foods. I just go in there and eat them. So I'm just going to, make it simple. I'm gonna say they have milkshakes. Yeah, I guess I never paid attention to, like, to actually get the names of those foods. I didn't really care since it's free. I'm just eating it. And they got French fries. Let's just say French fries. And these French fries cost $3.99. And let's just say for Pete's sakes, you know that when you go into the store, they have like counter stuff, like counter items, where when you're paying, they have the counter items. We're gonna just create a single catalog for this one item. So I'm gonna create another variable down here, var. And let's say they're selling a, I don't know, I'm gonna just say a keychain. And we're gonna say new catalog item, catalog, I don't even know what I said right there, item, I think that's what I said. And it's gonna be a keychain. And this keychain, since it's in a fancy restaurant, or not a fancy restaurant, fancy store, is going to cost us $6.99. Yeah, more than a milkshake or more than the fries. And I'm just going to get rid of all of this count to logs right here, because we're going to create another one. So we're going to log out. We're going to create, or actually, we're not going to log out anything right now. sorry about that. We're going to actually create a new catalog, a catalog group with all of these things, all of these groups that we created. So we created group shoes, group fruit, and this one single item catalog chain. So we're going to create a group. So var store, I'm going to just say store catalog. Man, dude, don't judge. New catalog group, and we're gonna name this group store, I guess, stored catalog. Okay, and the second item is, our argument is an array, and we're gonna pass in group shoes, and then group foods, and then our single one, which is a keychain. Bam. And there's no need for console log, because we already have print methods invoked inside of our methods. What? We already have our print methods. All right. And we do need to invoke that print method. And by the way, we're gonna do the total as well. So we're gonna log out. We're gonna log out. Let me use my ticks, because we're going to be logging out. Okay, the catalog total. So catalog store catalog dot total. No, that's not. Just it's not a function. It's a method. And down here, we're gonna actually do the catalog print. Okay, or it's a getter. But my bad. So store catalog dot print. Control save. So we got our total right here and our print. So let's see if it actually works. Up one, and I get object. That's wrong. Hold on, I'm gonna get it. But down here, you can see that we got store catalog, and we got our shoes group inside this catalog. Our shoes group, which it has this, our fancy food, and our keychain, which is awesome. We have that working. It's just the total is not working. Let me just fix that real quick. Okay, I do have it now. It's working. I'm not refactoring this. I'm not gonna just, although you could probably if you wanted to, but I'm not. But you get the total right here. If you're wondering what I did, I forgot to put the dot total right here. So make sure to do that. But anyways, we got the total, the whole total of the whatever is inside this catalog group, and we also got the catalog group. Let me just switch something around so it can make it look nicer. I'm gonna put the keychain first, and then this. Control save. Let me clear CLS, and then node. There we go. So we got the store catalog with the keychain $6.99, and then we got the shoes group, which is wingtip, shoes, kicks, flip flops, and fancy food, which inside there milkshakes and French fries. Awesome. So guys, this is the composite design pattern, and yeah, I mean, let's go into the pros and cons and when would you use this. All right, for the pros and cons. Now, the first two, you might be thinking this is kind of dumb, but let me try to explain it a little bit. So for the first one, less memory of object reduces the memory usage. Well, memory is extremely cheap nowadays, so this doesn't really matter. The reason I put this here is because I want to get you into the mindset of actually, if you could reduce memory usage, then by all means do it. Why wouldn't you want to do it? I'm trying to get you into that mindset of, like, you know, making your program better, no matter how much memory usage you're using or how little you could actually implement. It'll be better if you actually did it just a bit better. I'm trying to get you into that mindset. And the second one, we can reduce the execution time of our program by sharing objects. Like I said, JavaScript, Java, I mean, they're very fast at creating objects. This doesn't really matter, but like I said, I'm trying to get you into the mindset of actually creating something with, I guess, speed, right? You want speed. So if you can make it faster, then by all means do it faster. But yeah, like I said, these two, it's going to be controversial. So anyways, moving on. You can work with the complex tree structures more conveniently. Use polymorphism. There you go. Polymorphism. I was trying to, and recursion to your advantage. I think I said polymorphism. I haven't used that word in a very long time. Polymorphism. Anyways, you can introduce new element types into the app without breaking the existing code, which now works with the object tree, which is a good thing. Now for the cons, they're not really big cons, but alright. The composite design pattern makes it harder to restrict the type of components of a composite, so it should not be used when you don't want to represent a full or partial hierarchy of objects. Duly noted. The composite design pattern can make the design overly general. It makes it harder to restrict the components of a composite. Sometimes you want a composite to only have certain components. With composite, you can't rely on the type system to enforce those constraints for you. Instead, you have to use the runtime checks. Alright, moving on to the wins. So the wins, I mean, they're pretty much straightforward. Use the composite pattern when you have to implement a tree-like object structure. Alright, so this pattern provides you with two basic element types that share a common interface: simple leaves and complex containers. A container can be composed of both leaves and containers. This lets you construct a nested recursive object structure that resembles a tree. So use it if you want to have a tree-like object structure. The other one is use a pattern when you want the client code to treat both simple and complex elements uniformly. Okay, now for this one, all elements defined by the composite pattern share a common interface, right? So using this interface, the client doesn't have to worry about the concrete class of the objects it works with. That's why you would want to use it. That is it for this video, guys. Please leave a comment down below on where you want to use this the composite pattern. Dude, I don't know, but I think I've been stuttering a lot in this video. Maybe it's because it's 4 in the morning. I'm not too sure, or I haven't had my coffee. I think that's what it is. Anyways, thank you guys so much for watching this video. Please subscribe if you haven't. Please leave it a like if you liked it, or dislike if you disliked it for some reason. And yeah, I mean, again, I really do want to thank you, for taking time out of your day to watch this video. Anyways, I will see you in the next video. Thanks.